Hey guys, good morning. So you should have just completed the last quiz for Unit 1, and we're going to be moving on to Unit 2 here. So in this assignment, I included the concept outline or the success criteria for Unit 2. So here it is. We start with molarity and solutions. We're going to talk about the unique structure and property of water. Talk about what molarity is. I know you guys did actually some molarity and dilutions practice already, and we're going to kind of continue that a little bit later on. And we're actually going to talk about it today in the notes, and then we'll practice it a little bit more later on. And then we're also going to be talking about all the different types of reactions. So the reaction types, writing and balancing complete equations. We're also going to be doing complete and then ionic equations. We're also going to be doing oxidation reduction, and just looking at different types of reactions. So today we're even going to talk recognizing synthesis, decomposition, single replacement, all that good stuff, reactions. And you will need to complete the bookwork for this. I have not assigned a date for it just yet. However, you will need to do that. And I haven't assigned the SQ3R yet. I'm still up in the air about it. I want to talk to you guys about that and see if that's something that you guys think is useful or not. So we'll talk about that more in class today. And I'll ask you guys, see what you guys think. Okay. So let's get started here. We're going to be looking at the Unit 2 notes. So I did put a copy of it for you there. And so let's start with that. So types of reactions and solution stoichiometry, that's what this unit is all about. And let's see if it'll load today. There we go. Okay. So water is the common solvent that we're mostly going to be talking about. I mean, it's pretty much the only one we really talk about here in AP Chemistry. Maybe we'll talk about some other ones too, but water is the most basic one. The reason that water is a good solvent, it has a high specific heat, so it takes a lot of energy to heat up. It doesn't heat up or cool down too easily. It stays at a relatively consistent temperature. It has a high heat of vaporization, so it takes a lot of heat to turn into a gas. Has strong adhesive forces, so it sticks to other stuff really well. It also has strong cohesive forces, so it sticks to other water molecules. Cohesive, cooperate, they work together. Adhesive, they adhere to things, other things. Okay. One of the really crazy properties of water that is not common with other solutions is that it's less dense when it's a solid. Does anyone know what temperature water is the most dense at? No? It's 4 degrees Celsius. At 4 degrees Celsius, water is the most dense it can be. Okay, after that, as it gets colder, it actually starts to expand, and it expands and creates ice. It's a weird, very, very weird, very, very weird substance in that regard. Okay, the molecule itself, we should know what it is. It's H2O. It is two polar covalent bonds between oxygen and hydrogen. So if you do recall, polar covalent means that one side is positively charged and the other side is negatively charged. So in this case, the oxygen is negatively charged, hydrogen is positively charged. Okay? And the reason for that is because oxygen is more electronegative. It pulls the electrons closer to itself. Okay? The angle is slightly different than what it should be. So normally a bent molecule will have a 109.5 degree angle. However, it is slightly less than that. It's 104.5 degrees because there's two lone pair electrons on the oxygen, which push them together a little bit. Kiki says hi. Okay, hydration. So when water comes into contact with a salt, if that salt is soluble, it will what we call hydrate the ions. So basically just surrounding the ions. So it'll surround the negative ions by the hydrogens attaching to the negative ion, and surround the positive ions by the oxygens attaching to the positive ions, because oxygen is negative, hydrogen's positive in those instances, right? And typically the solubility depends on the attraction between water and water compared to that of water and the other molecule or other atom. Okay, if those attractions are similar, then we'll have something dissolve. So we typically say that like dissolves like. So two substances that have similar intermolecular forces, they will dissolve each other. Okay? So again here, like dissolves like. That is the general rule. Okay? So non-ionic substances, water can dissolve polar non-ionic substances as long as they have a positive end and a negative end. Okay? And they mostly dissolve, they do dissolve most, I shouldn't say most, some ionic solids, okay? But the general rule here is that like dissolves like. The more like the two substances are, the more they will dissolve one another, okay? Hydrogen does form hydrogen bonds. So hydrogen bonds are the attraction of oxygen, nitrogen, or fluorine to a hydrogen of another molecule. So the hydrogen, oxygen, nitrogen, or fluorine are usually the negative charges, and hydrogen has the positive charge. We'll talk more about hydrogen bonding specifically when we talk about intermolecular forces. Okay, we're not going to talk too much about intermolecular forces right now. Just know that the intermolecular forces have to be similar in order for dissolving to happen. Okay. When we talk about aqueous solutions, we're talking about substances that have electrolytes. And basically, electrolytes can conduct electricity. Electrolytes are the ions in solution. Okay. Strong electrolytes totally dissolve in water. Weak electrolytes only partially dissolve in water. Weak electrolytes typically do not conduct electricity, whereas strong electrolytes do. Okay. Acids and bases are usually strong acids and strong bases are electrolytes. So just some examples there. Okay. Okay. Non-electrolytes, they do not dissolve in water. They do not dissolve in water. They do not form ions in solution. Okay. So therefore, they do not conduct electricity. Okay. Aqueous solutions that are non-electrolytes, though, they do dissolve in water. Sort of dissolve, not really. Two examples are sugar and ethanol. Sugar and ethanol do not break down into ions. Instead, they just kind of disperse themselves throughout the solution. Okay, ethanol does it because the molecule ethanol is very, very similar to water. They have very similar structure. And same thing with sugar.
Oh, sorry.
Okay. That's all right. Okay, next, we're talking about molarity. So we did a little bit of molarity last time, and yes, it's pretty simple, just moles over liters. So number of moles over number of liters. One of the hints is you always add salt to water. Okay, you always add acid to water, salt to water. You always add to water. Okay, and the reason for that is because when things dissolve, sometimes they give off heat or they get really cold, and the water allows that heat or the energy to disperse more. It's not as concentrated, right? So if you were to put it, take a whole bunch of acid and then pour a little bit of water in it, it'd get really, 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 really hot, and that water would heat up and probably just like vaporize. Whereas if you take a bunch of water, add a little bit of acid to it, that heat can slowly dissipate into the water, can slowly dissipate into the rest of the surroundings. Okay, so we always add salt to water and not the other way around. Okay, this is just a picture of how to do that. So you see that in the first picture, they have the water already in the volumetric flask. They're adding the salt to it. They're stirring it a little bit. Then they're adding water up to the mark where the meniscus hits the mark. Okay, and that's typically how we make a solution using a volumetric flask. Okay, so here we go. Again, those are just the directions right here. Add a little bit of distilled water, measure out the solid, swirl to dissolve, add water to the mark, stopper to invert, and then you can standardize it. You standardize it, basically you're testing the strength of it. You do it 3 times. Okay. So here's some practice. You can pause the video if you'd like to practice these problems here. So you have 11.5 grams of solid sodium hydroxide, enough water to make 1.5 liters. You guys already kind of practiced this, so you can if you want, but the answers are down there. Also, the answers are on the bottom here too as well. So you can look at those problems. You don't even have to do them right now while I'm talking. You can go back and do them if you want, or if you get it, you get it. You can move on. Okay. Same thing here, all this stuff. Same. Moving on. Diluting solutions, typically we use this formula M1V1 equals M2V2. Again, we kind of practiced this already. If you guys have any questions or you want me to do any problems like that, I can do them. Okay. So more. Okay, let's talk about types of reactions. There's 5 types of reactions. You should have gone over this last year in chemistry. 5 general types: synthesis, decomposition, single replacement, double replacement, and combustion. So in synthesis, 2 or more substances combine to form one. Really simple. 2 things come together to form one. Okay, 2H2 plus O2 yields H2O. And that is, this is not really a perfect correct reaction, but that's okay. This should be 2H2 plus O2 yields 2H2O. But I don't know why I added that picture there. I should change it. Decomposition is when one thing becomes 2 things. Just breaks apart. Pretty simple. Single replacement. You have a pair of partners, so BX here, and then you have a single person, A, and A comes and takes the place of B. Okay, you can do anion replacement or cation replacement, doesn't matter. Okay, so you can remove the first one or the second one. That's single replacement. Double replacement, you have 2 sets of partners, and they switch partners. Okay, this one's the Swinger's reaction that I usually call it. And then finally, combustion. Combustion is you have a carbon-containing compound, so something like CH4, reacts with oxygen to form CO2H2O. The products are always carbon dioxide and water, and then a dead giveaway, carbon dioxide, water, and then oxygen in the reactant side. Okay, there's some practice with that. You can do that worksheet. Precipitation reactions. So precipitation reactions are a little bit tricky. These ones are mostly going to be double replacement or single replacement reactions involving looking at the solubility rules. Okay, you have to look at the solubility rules to see if when you form a double replacement or single replacement, does it form a compound that is insoluble? Okay, does it form anything that is insoluble? Okay, so you have your molecular equation here, the top one. Then ionic is all the ions. So you break everything that's aqueous, everything that is soluble, you write as ions in solution. And then net ionic is when you get rid of anything that doesn't change from the reactant side to the product side. So in this case, NO3, Na, and sodium, so nitrate and sodium, they do not change from the reactants to the products, so they're not in the net ionic equation. Okay, and I have some practice on that as well. If there's any problems that you want me to go over for that one, I can. So here's the worksheet, and it kind of goes over the directions and everything, what it means. You can use these solubility rules. These ones are okay. There are other solubility rules out there in the internet that you can use as well. I'll tell you what, that I do the answers for this, and I'll provide them to you in a second. I actually forgot to put them on there. There is like 1 or 2 that are a little bit questionable because the solubility rules aren't perfect. These ones aren't perfect, and I think there's like 1 problem in here that uses more different solubility rules. So do the best you can with those, and yeah, if you guys have any questions about that, let me know. All right. Other than that, if you guys have any questions, let me know, and I will see you tomorrow. Sounds good.